Good morning to all. This is Adaikalaraaj, St.Joseph College of Arts and Science, Autonomous Cuddalore. Now we have studied about the nucleophilic substitution reaction. Most of the organic compounds that have an electronegative atom or group bonded to an sp3 hybridized carbon atom undergo substitution reaction or elimination reactions. In a substitution reaction, electronegative atom or groups replaced by another atoms or group. In an elimination reaction, the electronegative atom or group is eliminated along with the hydrogen atom from the adjacent carbon. The atom or group is substituted or eliminated. This reaction is called leaving group. The most of the leaving group electronegative character bonded with the carbon atom. See the structure. The substitution reaction, only the halide ion replaced by nucleophile. In an elimination reaction, the leaving group will be eliminated along with the adjacent carbon containing hydrogen atom, that is beta hydrogen atom. The beta hydrogen atom eliminated by base or nucleophile. This is a nucleophilic substitution reaction. The nucleophilic substitution reaction have the two different mechanisms. The one is unimolecular nucleophilic substitution reaction. The another one bimolecular nucleophilic substitution reaction. The unimolecular nucleophilic substitution proceed by the carbocation intermediate. The bimolecular nucleophilic substitution reaction, not formation of intermediate. The intermediate means generally carbocation carbon intermediate. In nucleophilic substitution reaction, unimolecular nucleophilic substitution reaction have carbocation intermediate, but the bimolecular nucleophilic substitution does not formation of intermediate. It is only 5-member transition state, formation of 5-member transition state. SN1 reaction mechanism. The SN1 reaction mechanism followed by two-step process, where in first step formation of carbocation, and then second step the nucleophile added on the carbocation. Finally, deprotonation of the protonated nucleophile takes place to give a required product. See the mechanism. In the step 1, the L means leaving group. Generally the leaving groups are electronegative character or electronegative part. The electronegative character of atom or group will be eliminated or leave with the carbon have positive charge of ion because of the bonding electrons itself to the leaving group. Again the second step, the formation of carbocation is stable carbocation. Generally primary carbocation is less stable than secondary, is less stable than tertiary. The tertiary carbocation is more stable. It is more applicable for the unimolecular nucleophilic substitution reaction, that is SN1 reaction. In the second step, the nucleophile added to the stable carbocation. The reaction is a fast reaction to formation of nucleophilic substituted product. Stereochemistry of SN1 reaction. There is a bromo-octane. The bromo-octane means positive bromo-octane means as a R configuration. The ionization, the bromide ion will be leave. The bromide ion will be leave formation of carbocation. The carbocation is one of the secondary carbocation. Generally it has the slightly planar structure. The planar structure means the carbocation carbon atom have sp2 hybridization. It has 120 degree. 120 degree means planar. The nucleophile added either in front of plane or back side of the plane. Generally the planar carbocation have the planar structure. The planar structure have the carbocation attacked by either nucleophile front side or back side. In the front side attack, formation of retention configuration of the product. Suppose the nucleophile added to the back side, the formation of product is an inversion configuration of the product. 50% of retention product and 50% inversion product formation of racemic mixture. The racemic mixture generally formation of SN1 reaction mechanism. The energy diagram of SN1 reaction mechanism. SN1 is a multi-step reaction, so the diagram has multiple curves and each step can be represented by one curve. Out of these three steps, first step, formation of stable carbocation, and second step, the nucleophile added to the carbocation, and third step, the disprotonation by the nucleophile. First step, see the structure. Energy present in the y-axis, x-axis have reaction process. On the left side, bottom, alkyl halide is one of the tertiary alkyl halide. The tertiary alkyl halide, when leaving group will be leave formation of stable carbocation. The red color line mentioned in the activation energy, highest line mentioned the activation energy, and then in the bottom, slightly bottom side have the tertiary carbocation. As I mentioned, the carbon bonded with 3 alkyl group, that is the tertiary carbocation. Tertiary carbocation is more stable carbocation. Again, the nucleophile added to the carbocation to formation of stable substituted product, that is nucleophilic substitution product. This reaction, starting material alkyl halide, the energy will be lowest in the product. So the reaction is one of the exothermic reaction. Generally, the exothermic reactions are liberation of energy. The liberation of energy means that product is a more stable product. SN2 mechanism. The carbon nucleophile bond forms the carbon leaving group bond breaks simultaneously through the transition state. In generally, the SN2 reaction, the nucleophile added to the sp3 hybridized carbon atom, the nucleophile must be strong nucleophile. The leaving group at the same time simultaneously leaved by nucleophile. Now the leaving group is pushed out of transition state on the opposite side of the carbon nucleophile bond, forming the required product. Reaction, alkyl bromide, generally alkyl halide, the name of methyl bromide, react with hydroxide ion formation of methyl alcohol, leaved bromide ion. See the reaction. This is sp3 hybridized carbon atom. The bromide ion will be bromine bonded with the sp3 hybridized carbon atom methyl group. The nucleophile is a strong nucleophile pushed react with or attached with the sp3 hybridized carbon atom to formation of transition state. The transition state means pentagon coordinated carbon. Pentacoordinated means 5 atoms are directly bonded with the carbon. It has a positive charge. When the bromide ion will be leaved to formation of stable product. The structure considered as a umbrella flipped inside and out. There is an inversion product. Generally, SN2 reaction possible nucleophile added in the only backside attack. The product is a inversion product. The energy profile diagram of SN2 reaction. The energy changes for the above reaction can be represented. The energy diagram shown in figure SN2. This is a single step reaction. Already we know the SN2 reaction is a simple step reaction because the nucleophile added to the sp3 hybridized carbon at the same time leaving group will be pushed out from the sp3 hybridized carbon or alkyl carbon. So the reaction is a single step reaction. The product of methanol and bromide ion are lower energy than the reactants methyl bromide. This reaction also exothermic reaction only for the pentagonal or 5-member transition state, does not formation of intermediate. Likewise SN1 reaction. In SN1 reaction formation of stable carbocation, but in the SN2 reaction not stable carbocation. It is only proceed by the 5-member transition state or pentacoordinated transition state. So the reaction is one of the exothermic reaction, and the product also more stable product. Stereochemistry of SN2 reaction. The another features of SN2 reaction mechanism, the overall configuration of the product carbon gets inverted compared to that of reactant, like an umbrella flipped inside out. Such inversion of the configuration is called Weldon inversion. Generally, Weldon inversion means the nucleophile added to the backside, the leaving group will be eliminated. This products generally formation of inversion product. Steric accessibility of the nucleophile center in the substrate, the probably most important factor that determines if a nucleophilic substitution will follow SN1 or an SN2 mechanism. The comparison of SN1 and SN2 reaction mechanism. First, SN1 reaction is a stepwise mechanism, forms a carbocation intermediate. Already we know in SN1 reaction formation of stable carbocation. The stable carbocation formed by the sp3 hybridized carbon attached with the electron donating group of alkyl or aryl group. The electron donating groups are stabilize the carbocation. But in SN2 reaction, it is a one-step mechanism. In SN2 mechanism, one-step mechanism, only the reaction we have only for the transition, not transition state, only we have the 5-member coordination number of transition state. The SN1 rate determining step involves a single molecule only for substrate. The rate of the reaction depends on only for the substrate, not for nucleophile. But in SN1 reaction, rate determining step involves both nucleophile as well as substrate. It involves rearrangement carbocation. Already we know the SN1 reaction generally involves the carbocation intermediate. No rearrangement of the carbocation in SN2 reaction. In SN1 reaction, compare the reactants products both inverted and retained configuration. Because of it has a racemic mixture in SN1 reaction product. Already we know the carbocation have the planar structure. The planar of the carbocation, the nucleophile either added front side or back side. But in case of SN2 reaction, not carbocation, only 5-member transition state, the formation of only inverted product. The nucleophile added or attached to the sp3 hybridized carbon atom in backside of the leaving group, pushed out the leaving group by the nucleophile. So therefore SN2 reaction is inversion configuration. The reactivity order of substrate, tertiary alkyl halide is a more stable or more reactive compared with secondary alkyl halide and compared with primary alkyl halide. The primary alkyl halide means methyl or ethyl. Ethyl and propyl alkyl halide also primary alkyl halide. The reactivity order of SN2 reaction, tertiary alkyl halide is a least reactive. Because of tertiary alkyl halide, the sp3 hybridized carbon atom attached with 3 alkyl group. The alkyl group means bulkier group compared with hydrogen atom. Therefore, the SN2 reaction, bulkier group bounded or covered by the sp3 hybridized carbon atom, does not nucleophile added to the backside. So the SN2 reaction is a least reactive or no reaction in the tertiary alkyl halide. Secondary alkyl halide is a moderate reactive. Primary alkyl halide is more reactive in SN2 reaction. Thank you.